All right, you guys, we're going to finish off our discussion about slopes of lines with two special lines. We have parallel and perpendicular lines, okay? So what it means for your lines to be parallel, it means that the lines have the same slope and they have different y-intercepts. And as a result, those lines never intersect. They never cross one another, okay? So it's kind of like when you're parallel parking, the whole goal is that you do not hit the curb, okay? You do not intersect the curb. You are lined up with wherever you are trying to park, okay? So the important thing to remember about parallel lines is that their slopes are the same, okay? Now, on the other hand, we also have perpendicular lines, okay? Perpendicular lines cross, okay? And a cool thing in geometry is that they actually create 90-degree angles, but that's beyond the scope of this discussion, okay? All you have to know is that perpendicular lines have opposite and reciprocal slopes, okay? What this means is that they are opposite in sign. So if your original line is positive, then your second slope is negative, and it also means that it's flipped, which is the reciprocal part. So they are opposite and reciprocals, okay? So let's look at an example. Okay, so in this example, they say determine if the lines are parallel, perpendicular, or neither. Okay, so let's look at number 1. So line 1 is y equals negative 3x plus 7, and line 2 is y equals 1/3 x minus 4. Now, before you can determine if you have parallel, perpendicular, or neither lines, remember that your lines must be in slope-intercept form in order for you to make that distinction. Okay? Remember, they need to be in slope-intercept form because that is the only form that by looking at the equation, you were able to distinguish the slope and the y-intercept. So if we look at the lines that they gave us in number 1, we can see that our lines are in fact in slope-intercept form. So we don't have to do any additional work here. So now all we need to do is identify the slopes. Well, for line 1, the slope is negative 3, and for line 2, the slope is 1/3. So we ask ourselves the question, well, are these lines parallel? Well, no, they're not parallel because parallel means that their slopes would be the same, and we can tell that they're not. So they're not parallel. Now let's see if they're perpendicular. So perpendicular means opposite reciprocal. Well, my first slope is negative and my second is positive. So it's got the opposite part down. Let's see if they're reciprocals. So if I put 3 under 1, would I get 1/3? Yes. So these lines are perpendicular. Okay. Cool. All right, let's look at the second one. All right, for number 2, our line 1 is y equals 2x plus 1/2, and line 2 is negative 6x plus 3y equals 15. Now remember, before you can make the distinction if they're parallel, perpendicular, or neither, your lines have to be in slope-intercept form. So when we're looking at our lines that have been given to us, the only line that is already in slope-intercept form is line 1. So we have to fix line 2. So that's the first thing we're going to do. So we have negative 6x plus 3y equals 15. And I'm going to put this in slope-intercept form, which means that y needs to be isolated. So I'm going to add 6x to both sides. That's going to give me 3y equals 6x plus 15. And then I'm going to divide both sides by 3. Okay, so that gives me y equals 2x plus 5. So now I'm comparing this equation, okay, to the original one they gave me for line 1. So I look at their slopes. Well, the slope for the first line is 2, and the slope for the second line is also 2. Now, since those numbers are the same, we now have parallel lines. Okay, So the important thing is when you're trying to classify is always make sure that your equations are in slope-intercept form first. And then if your slopes are the same, you have parallel lines. And if your slopes are opposite and reciprocal, then you have perpendicular lines. Cool?